Hey ladies and gentlemen, this is Ms. Hemrad here, and we're going to be doing Unit 2 Notes 5. So we're going to talk about solving systems using any method. So we've learned all of the methods that we can use so far, and now we're going to learn when to identify which method is best to use. Now when I say solving methods, I'm talking about elimination versus substitution. Okay, so substitution is typically the easiest to use when it's solved for a variable, it's already in slope-intercept form, or it's something that's really easy to solve for a variable. There's a letter that has a number 1 with it. There's no other number in front of it or something like that. That would be easiest to use substitution. When to use elimination? If your answers are in standard form. If you already have those same numbers and opposite signs, or if you also have just the same number on the same variable in both of the equations, that would also be a really good time to use elimination. So let's take a look at some examples. So I'm looking at number 1, and I see, first of all, that it's already in standard form. Not only is it already in standard form, but it's already set up with same number, opposite sign. So that means elimination would be really easy to use because these are already opposite. It's already in standard form. So I can go ahead and add down the columns. So 3x plus 2x is going to give me 5x. And these y's are going to cancel out. 7 plus 13 is going to give me 20. So now I'm going to divide both sides by 5, and I get that x is equal to 4. So x and 4 are the same thing, so I can pick which one I want to substitute it back into. It doesn't matter which equation. Let's just plug it into the first one. So we have 3 times 4 minus 5y is equal to 7. Well, 3 times 4 is going to give me 12, minus 5y is going to give me 7. So I'm going to subtract 12 from both sides, and I end up with negative 5y is equal to negative 5. Well, that's easy enough. I can divide both sides by negative 5. When I do that, the two negatives cancel, and I'm left with a 1. Now I want to write it out as the coordinate point x, y. So first I want to take a look at my x, which is 4, and then my y, which is 1. So the answer to this one is 4, 1. Next, let's take a look at number 2. Now I see for number 2 that it's already solved for y. It gives me y equals. So that means the easiest way to use is substitution. Does that mean you can't use elimination? Absolutely not. If you want to use elimination, you can. But to me, this one's easier to use substitution because it's already solved for y. So what I'm going to do is I'm going to rewrite out the equation. Now, instead of writing y where I see this, I'm going to take this part out right here and put that in instead of the y. And now I'm ready to solve this for x. So the first thing I'm going to do is distribute that 3. So I get 5x plus 6x is equal to minus 30 is equal to 3. Now I'm going to add 30 to both sides, and I'm also going to combine these terms. So 5x plus 6x is 11x. 3 plus 30 is equal to 33. So now I'm going to divide both sides by 11, and we get that x is equal to 3. So x and 3 are the same thing. So where I see x up here, I'm going to put in 3 instead. So I have y is equal to, now instead of writing 3, I'm going to put 2 times 3 minus 10. So instead of writing x, I put 3. Well, 2 times 3 is 6, so I have 6 minus 10. So 6 minus 10 is a negative 4. So y is equal to a negative 4. And now I'm going to write that out as a coordinate point. First my x, and then my y. Next, let's take a look at number 3. So first of all, this is in standard form, but I don't have my variables lined up. So I'm going to start by doing that. So I'm going to flip-flop these x's and y's. So I'm going to bring it to be 3x plus y is equal to 24. 5x minus y is equal to 8. So now I see that it's set up for elimination. I have opposite signs with the same number. So that means I'm all ready to add down the columns. Well, my y's are going to cancel out. 3x plus 5x is 8x. 24 plus 8 is going to give me 32. So then we're going to divide both sides by 8, and we end up with x is equal to 4. So x and 4 are the same thing. So where I see x up here, I can put in 4. So I'm going to do that. Let's do that with the top one. So I have y plus 3, and then I'm going to take x out and put 4 in instead. Now, it doesn't matter which one you plug it into. Remember that. So I have y plus 12 is equal to 24. So to solve for y, I'm going to subtract 12 from both sides, and I get that y is equal to 12. So I'm going to write it out as a coordinate point, first my x, then my y. So 412 is my answer for number 3. Now taking a look at number 5, it's in standard form. You may want to look at this and say, okay, it's not easily to use substitution, so I want to use, it's not easy to use elimination, so I want to use substitution. Well, the fact of the matter is it's not going to divide nicely if we use substitution. I don't want to have to deal with fractions. So I'm going to use the more difficult version of elimination. I see that my y's already have opposite sides. Now I need to make them have the same number on the outside. Well, what's the smallest number 3 and 5 multiply to? That's going to be 15. So I'm going to take this top equation and multiply it by 5, take this bottom equation and multiply it by 3. So now I'm going to go ahead and distribute that in. So I get 25x plus 15y is equal to 5 times 16, which is 80. And then I have 9x minus 15y, because we're distributing that 3 now, is equal to a negative 12. So then I get 9 plus 25x, that's going to be 34. These are going to cancel. 80 minus 12 is 68, and there should be an x there. So now we're ready to solve this for x. So I'm going to divide both sides by 34, and I end up getting that x is equal to 2. So x and 2 are the same thing. So where I see x in one of these two equations, I can plug in 2. So I'm going to do that on the first one maybe. So I have 5 times 2 plus 3y is equal to 16. So now I'm going to solve this for y. 5 times 2 is 10. Plus 3y is equal to 16. Then we're going to subtract 10 from both sides, and we get 3y is equal to 6. Divide both sides by 3, and we get that y is equal to 2. So x is equal to 2, and y is equal to 2. So your final answer for that one is 2, 2. Moving on, let's take a look at these problems. So now I see that number 5 is already solved for y. Y is equal to 4x plus 1. So where I see y down there, I'm going to plug that in. It's easy to use substitution on this one because it's already solved for a variable. So I'm taking y out completely and putting that 4x plus 11 in instead. So now I'm going to start by distributing that negative 2. Negative 2 times negative 4 is negative 8x. Plus a negative 22 is equal to a negative 7. Okay, well 3 minus 8 is going to give me negative 5x minus 22 is equal to a negative 7. Then I'm going to add 22 to both sides. So then I end up getting negative 5x is equal to 15. Divide both sides by a negative 5, and I end up with x is equal to a negative 3. So now I know that x and negative 3 are the same thing. So I can plug in for x right there. Now I'm going to choose the first one because it's already solved for y. That makes it easier. So now what I'm going to do is I'm going to plug in that negative 3. So I have 4 times negative 3 plus 11. So then I get negative 12 plus 11. And so I get that y is equal to negative 1. Now I want to write my answer out as a coordinate point. First my x and then my y. So this right here is their final answer for number 5. Let's take a look at number 6. So number 6, again, it's set in standard form, and to me there's no simple way to solve it if I wanted to use substitution. I would get a bunch of variables. So what I'm going to do is I'm going to use elimination again. So I see that I have opposite signs here. So now I want to make those two have the same number on the outside. Well, what's the smallest number 3 and 4 multiply to? Well, that's going to be 12. So in order to get 3 to be 12, I need to multiply by 4. In order to get 4 to be 12, I need to multiply by 3. So I'm taking each of those equations and multiplying them by something new. So I have 16x plus 12y is equal to 76. And then I have 9x minus 12y is equal to 24. So then I get 16 plus 9x, which is 25x. My y's are going to cancel out. 76 plus 24 is going to give me 100. Divide both sides by 25, and then I get that x is equal to 4. So x and 4 are the same thing. So where I see x up here, I can go ahead and plug in 4. I'm just going to plug it into the top one. So I have 4 and now I'm taking x out and I'm putting 4 in instead, plus 3y is equal to 19. So now I'm going to multiply 4 times 4, which is 16. And I want to get that 16 over to the other side. Well, since it's positive, I'm going to subtract 16 from both sides. And I get that 3y is equal to 3. Last but not least, I want to divide both sides by 3. So I get that y is equal to 1. So now I'm going to write that out as a coordinate point. First my x, and then my y. So my answer then is 4, 1. Okay, so let's take a look at these word problems here. So, Deshawn and Shawnee are selling flower bulbs for a school fundraiser. Customers can buy bags of windflower bulbs and bags of daffodil bulbs. So, Sean sold 10 bags of windflower at price X. So, I'm going to let X represent the price of windflowers, and 12 bags of daffodil bulbs at price Y. And that added up to 380. And then Shayna sold 6 bags of windflowers at price X and 8 bags of daffodil at price Y, and that was $244. So to me, this looks easiest to use elimination. Okay, so I see that I have X, or I have it in standard form. So to me, the easiest thing to do would just be to flip coefficients. Well, let's look at it this way. Let's take a look at 6 and 10. Well, what's the smallest number that 6 and 10 multiply to? That's going to be 30. So in order to get 10 to be 30, I need to multiply by 3. But notice currently that I don't have opposite signs. So I need to create opposite signs. So what I'm going to do then is I'm going to make this one that I multiply be negative. Well, how do I take 6 and make it negative? Well, to get it to 30, I multiply it by 5. So let's go ahead and write out our new equation. So we have 30x plus 36y is equal to 1,140, and then we have negative 30x minus 40y is equal to a negative 1220. So now I'm ready to solve by elimination, and this should have a y with it. So here I'm going to end up with a negative 4y, and then we're going to take and we're going to add down that column there, and I end up getting a negative 60 here. So now I'm going to divide both sides by a negative 4, and I end up with y is equal to 15. Now that 15 represents our pounds of, or our bags of daffodil. So I want to make sure that I note that it's daffodil. So what I want you guys to do is go ahead and figure out what X is going to be. Let's take a look at this last word problem. I'm going to get it set up, and then I'm going to have you guys solve it using elimination. So at a store, a toothbrush costs X dollars and a soap costs Y dollars. So a customer bought 2 toothbrushes at price X and 1 bar of soap at price Y, and that was 11. Another customer bought 2 toothbrushes at price X and 5 bars of soap at price Y, and that was $38. So my suggestion for you to solve this would be to multiply this guy by a negative 5. That's going to create the same number in opposite signs. So then when you multiply that top one by a negative 5, you end up with negative 10x minus 5y is equal to negative 55, and then 6x plus 5y is equal to 38. So I want you guys to solve this using elimination. Please make sure you check that you label both of them, and make sure you take the Schoology quiz once you're done. Thanks for listening.